can see there's a difference between solid mass wasting, so that's dominated. There's no liquid involved. It's just mass wasting, and then these gullies. There's obvious differences. These, the V-shaped channels, your depositional apron that shows like meandering channels. There's huge differences. So that's pretty much. They're saying, okay, if it's not, just mass wasting of solid material, what is it? And they, these gullies look exactly like gullies that you see on Earth. So we go water. It's always the assumption that you kind of jump to. They're formed by liquid water on Earth. They look exactly like things on Earth, so they're formed by liquid water on Mars.
Okay, you can then speak.
I don't want you to be confused.
I'm not sure.
Like this paper, like.
Sure, I'm subtle. I think my problem is I'm mixing the two together.
You are. They're different. The channels, like.
They're calling for mechanisms that just don't exist.
Yeah. They're different. The impact crater and the gully formation is completely different.
So they're claiming that there is recent superficial fluvial activity.
Yes, that was like that claim in this paper. The two claims was recent impact cratering and recent fluvial activity on Mars. And here's our proof. We have pictures of them.
So they're saying that it's like melting of the cryosphere that's causing this?
Potentially. I mean, maybe. They're saying like with the whole ice damming process, maybe it was already liquid because you have high enough temperatures and pressures, and it's just like kind of frozen right at the edge.
Yeah.
And then and you get kind of like increased pressure, and then it just busts the dam, and you get ice and water flowing out onto the surface, which they said like if there's a significant ice component to these outflows would explain like their features more than if it was just like pure liquid water.
Yeah.
They said like we talk about how like these outflows are like they kind of look like really high viscosity outflows. Like there's lobes that you can see on the depositional apron that flow and they stop like halfway down the slope. They don't reach like the base of it. So there's like you can see multiple lobes like going over top of each other. So they're kind of invoking a high viscosity something.
So they associate them at all with cryokarstic features? Because they would think if there's this abundance, if the cryosphere is being melted beneath the surface, especially at equal depths around an entire area, you would expect that the surrounding area would also show like sinkholes and would show some other features.
I don't think you need to invoke like karst features and get sinkholes because they're just talking, just regular groundwater.
Maybe it's not flow.
But it's not regular groundwater because it's the cryosphere, and then it's disrupted, and then the water flows, and then presumably refreezes.
Yeah, but at a certain depth, they suspect you get liquid water.
Mm-hmm. And that's where they're saying this depth is right around the area where these features, because they said in a single impact crater, all of these channels originate from like the same level in the crater.
And back wasting? Is it eroding back?
And headward erosion. You see that.
And what about the material above it? That remains. I mean, like if we look at the figure, where the big black spot is, if that's eroded back, so all the material above it is no longer stable.
Yeah, and
so does that slump as well? Does it continue
this
headward erosion
yep.
beyond the point where they think that
it works exactly how you would think it would. You get headward erosion. They said they can see in several of the gullies, you can see blocks that have, there's material in like the incised. So I guess like if you have your slope here, you have your point of originate, like the water coming up here, you're going to get, headward erosion as this material becomes more and more unstable.
Yeah.
And they said kind of in the top, they said there's material that you can see has slumped in there, has fallen in there. There's blocks of material that fall into the head alcove.
You can see kind of like a hanging section in the figure too. the outcome area, it just looks like it's hanging right there.
Yep.
And you would think that just eventually, even if it was just a manual process.
Is there any evidence of that flow or of that headward erosion, the sediment ending up in the outwash at the bottom?
What do you mean?
Like if there was liquid water flowing through there and eating away the material, wouldn't it ride the liquid water down, maybe?
Yeah, and it does.
That's what I'm asking. Is it down at the bottom?
Yeah, like it. I mean, obviously these are single pictures from single point in time. So they said you can see chunks of material that have fallen in, but I mean it's the same process. It gets carried through the channel and deposited in the apron.
You're saying isn't there like a cooling kind of?
Like a fluvial fan.
That's what the apron is. Is like your fan, your depositional apron.
Small deposit. Mm-hmm. They've definitely speculated the constituents of such deposits and said that it's likely that these little aprons at the bottom are composed of remnant ice, frost, and even precipitates that are kind of just taken up with the fluidized movement.
Mm-hmm.
I think of the other point I was trying to make.
Where does the water get before it evaporates? Because it would just be like, once it reaches that low pressure, it would just boil.
Yeah, it would just sublimate immediately. Like this, they talked about that's why you need like kind of a higher viscosity fluid. You need ice and material in it because with ice and with all the sediment that it's picking up, it's going to increase its pressure. And so it would get a little bit farther before it would sublimate. But yeah, I mean this stuff is going to sublimate real quick.
Some of them are a few hundred meters long though. I mean.
That's why. I think that's what you said. Why it's kind of low bait because because certain parts
it's
get
sublimating and
then the water's gone and this will make it slow.
Exactly. Yeah, but like Mars said, there's a lot of them. There's several hundred meters long. They're not. Obviously there is tiny couple meter ones they can see and stuff, but they get pretty big. So it's not.
If there's a lot of water, it would take some time.
Mm-hmm. It would be a significant. It is a significant amount of water, like one kind of outburst. Which I think kind of goes along with like I like that whole ice damming thing because like keep building up pressure in your ice dam, and then it breaks, and you get a real quick decrease in pressure as all the water goes out, and then as pressure decreases, kind of coming out of the rocks, then it's going to start freezing again and form another ice dam. You just kind of get this episodic nature of these.
You guys buy it, knowing that all the things we've talked about on Mars?
I think it's plausible.
I think it's continuous, not like continuous flow, but like.
I mean, well, I think like. Yeah, I think definitely. I mean, you have these significant depositional aprons where there's multiple lobes upon lobes of deposited material, so they can't just be one event and then it'll never happen again there. Like it has to just continue to happen.
Should we talk about light?
Sure. We're gonna take a break real quick.
Yeah.
Go to the bathroom.
Break time.
5-minute break.
5-minute break, and then we'll talk about life.
How reconvene.
How it's not there.
I don't know, I saw a face.
Yeah, check
Saw that face. Yeah.
Check the video.
Yeah. I mean, it's still running.
Sequel would be so funny.
I went around 7 times.
Sorry I'm late, I was in the roundabout
You're
for
stuck
like
in the
20 minutes.
Alright, so life.
Life. Searching for life.
Mm-hmm.
So, what do we think we know about Martian conditions?
Martian conditions relevant to biology. Well,
Extremely inhospitable today.
pretty much, yeah. Sums up pretty much.
Sums up.
Thin CO2 atmosphere doesn't retain any sort of daytime heating. That's a bad thing. The average temperature ranges from 130 to 250 K, where organic temperatures like to be around 253 K.
Is that right though? Didn't we talk about temperature before?
I think that was right.
Yeah,
Alright,
I think
so
that was.
sometime.
I think that was it. 130 to 250 K.
What if the life on Mars
Let's
just
make
has
a table.
sweaters?
Sweater life.
Here's my idea. Let's make
Well, see,
start with
like
a
that's
table
the thing, you know. Obviously, life.
of the
it
conditions to consider if we're gonna look at could there be life, could there not be life. We can look at the conditions that they're saying make it so there's can't, and then later think about ideas of where places may exist on Mars where these conditions aren't exactly what the average is, you know. Because the surface temperature is one thing, that's not the temperature in every single location.
Obviously not.
So
It just means no surface life.
right, which we pretty much know. But we're not there yet. So let's look at the basics. That's how we do things. So temperature is a problem.
Pressure.
What is it, 240 K?
Yeah, that's average.
Pressure. What is it?
Range.
What did you say? 0.08.
It can be as high as like 14 pascals in Hellas. I think that was the
Yeah,
highest.
it can get high. The average was like
0.08 atmosphere.
0.08.
Atmosphere.
Atmosphere.
I think they said it was 20 millibar or something like that.
Then there's this radiation.
Radiation.
But
That
only
wasn't-
sometimes.
Yeah,
right?
well, that was like the whole thing
Solar
with that
flare
is
events,
like
yeah.
they didn't have there was no like outburst. That was pretty much like a base level of how much radiation when they measured it. It was a base level of how much radiation you would normally receive. There was no solar flares. There was no ridiculous cosmic events.
Okay, so they say 18 to 28 millirad
Mm-hmm.
compared to Earth, 30 to 45.
Right, but it was the big events.
Per year. So, right, so the problem is during solar flare events.
Yeah,
Yeah,
and it was even a solar flare that killed the marine.
Killed the equipment.
Yeah,
So,
that was fun.
What's the
killing the
frequency
marine,
of
killed
solar?
marine.
What's the frequency of solar flares?
I don't know.
Does anybody know?
If you go by that one incident, it's at least once every 19 months.
No, I know they're often because
It depends on what
they're
the
often
cycles
because you're
of the
not
sun.
supposed to fly late pregnancy for that reason. Solar flares
Yeah.
can induce radiation because of birth defects.
Yeah.
The sun has different
Oh, that's
periods.
what they
Yeah,
say.
it's
There's
coming
a lot
into a
of-
more active period now, so
Yeah,
obviously
it's
we're
been
gonna have
like
more
pretty
solar
volatile.
flares, more potential of high doses of radiation now.
There was a solar flare they experienced in
one.
California not too long ago. My sister told me.
They had it was like last week they took
They turned green for the day or something.
No, they just it was just a little warmer that day.
So-
I don't know.
Stand
exactly
really
what
quickly.
it was.
California got a little nicer.
Yeah.
So-
it wasn't
Solar
really.
flare
They couldn't really tell, but
Something.
And then
they were warned about it or whatever.
The main problem was the UV radiation.
Higher radiation.
Yeah.
Because there's no ozone. It separates like a little bit over the poles.
Yeah.
So they said the UV radiation is just gonna just come in and just destroy any sort of DNA that you have on the surface.
Do we have a value to put? There's like, was
No.
it 3 times?
No.
Yeah.
Those-
3
yeah.
orders of magnitude.
Yeah, 3 orders of magnitude
More
higher
damaging.
than we get on Earth.
Higher than Earth.
Mhm.
Is that higher than the worst places?
I don't know.
Is it very
Higher than Earth.
Yeah,
Average.
obviously it varies, but I'm sure it's just an average.
average?
It's always just an average.
Oh, it's just,
Oxidizing.
okay.
Mhm.
Highly oxidizing. Yes. They sound like hell.
Obviously the lack of water.
Lack of water.
So, the biggest problem I have with this is
Are we at that point in the discussion?
For Adam, yeah, we're always at that point in the discussion.
I'm
for Adam.
definitely. Well, I just want to point something out. They're using all these parameters, saying that life as we know it here on Earth probably couldn't exist very well. What about life? You know,
That's why there's the qualifier as we know it. Life as we understand how it works on Earth. because
well,
it's
even
only analog.
even using what we understand about life and evolution, couldn't.